let's suppose that you have two equations, y equals 3x plus 1, y equals x minus 2.
No, I can't see that.
Okay. All right, so we have two linear equations, and they both start out y equals y equals. What we learned yesterday is, well, we would just go to y equals, type them both in, do second trace 5, wait, enter, and it gives us our answer. Obviously, if you're at home and you don't have a calculator, you can't do that. So what do? Well, you graph both of them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The first one starts right here at positive 1, so boom. And then you go up 3, 1, 2, 3, over 1, boom. Draw your line. The second one starts right here, negative 2, so negative 2, and then you go up 1, over 1, boom. Draw that line.
Hold on, Mr. Mackey, my pencil just broke.
Oh my.
Continue.
Here's the solution, right there where those two lines cross. And that's going to be, I didn't draw my unit measures even, but that's going to be just about negative 3, negative 4, or negative 5. The alternate to that is this says it's equal to y, this says it's equal to y. If they're both equal to y, then they are equal to each other. And so you set them up like this. 3x plus 1 equals x minus 2. Now first you're going to solve for x. So get answer for x. That's step 1. Okay, you can move up closer.
It don't help. Yeah, it doesn't.
Okay. This is the best I can do. I can't turn the lights out because then you won't be able to see to write. I mean, it's all or nothing. So let's just get through this, and then.
I'm not trying to go on phone. I'm just trying.
Move closer.
No,
I can see it.
I don't know what you're saying.
No, I'm not trying to call you. I was just trying to tell you there's a dim if you didn't know.
Okay. That's just the best I can do. If you're having trouble seeing it, move closer if you need to. That's the best I can do. All right, get the answer for x, which means solve this for x. Minus x, 2x plus 1 equals negative 2. Minus 1, 2x equals negative 3. Divide by 2, x equals negative 1.5. Well, I sure drew my lines wrong. So we have half the answer. X is negative 1.5. Now get the answer for y. Try this. Bear with me just a second. I don't know if that made it any clearer or not.
No, it's like your board's dirty. Like,
Okay, we're in Ector, Texas, which in a lot of ways is great, but this is what we have to work with. Okay, how do we get the y? The y relies on you having a value for x. Now we've got a value for x. Now we're going to go up here and either plug it into this one or plug it into this one to solve for y. You'll get the same answer no matter which one you plug it into. I think this one will probably be the easier one. So we go over here and we do y equals, and instead of x, we're going to do negative 1.5 minus 2 equals negative 3.5. So it's pretty close on that one. So my solution is negative 1.5, negative 3.5. I have an x and a y. There's the answer. If I had drawn my coordinate system out a little bit better and drew my lines better, then this point would have ended up about right here, and we would have just been able to take it off the grid. If you don't use the calculator and y equals, then you either have to do this or this, and either way will get you the answer.
I kind of like this way.
Okay. That is when both equations start out with y equals. Now there's nothing that there's nothing that says you have to keep an equation the way that they give it to you. No matter how they give the equation to you, you can change it to this form and do this method. Right, elimination. No graphing involved in this one. This is what we use when we have equations that are both in standard form, like 4x minus 3y equals, let me work it out in my head so I'll get something that works. Okay, so negative 1 and 2x plus y equals 11. These two equations are in standard form, and by that means that the x and the y are both on the same side of the equal sign. Yesterday we used matrix to solve these. It's very fast and efficient once we get used to the steps. If you don't have a calculator to use, you'll have to do it by hand. And the way you do it by hand is you try to find either the x's with the same number in front of the x or the y's with the same number in front of the y's. If they're not already set up that way, then you have to multiply at least one of the equations by some factor so that you have something that matches up. For example, the second equation, we could multiply it by 2 and we would have a 4x here. And it would match that one. Or we could multiply this equation by 3 and then the y's would have the same number in front of them. Which one is it, Savannah? Which one do we want to do? You say repeat the first part? We've got to multiply the second equation by some number to either match the x's or match the y's. So do you want to multiply by 2 or by 3? 3? Okay. So we're going to multiply the second equation by 3. If we multiply the whole thing, it doesn't change the value of anything. So now my two equations are 4x minus 3y equals negative 1 and 6x plus 3y equals 33. Now, why are we doing this? We're doing this because we're going to be able to eliminate either the x's or the y's, and we will have one equation with just one variable so that we can solve for that one. The logic part of this is, now that your y's both have the same number in front of them, do you need to add the two equations together to make the y's go away, or do you need to subtract? You need to add. So I'm going to put this in parentheses with the plus sign on the outside. So 4 plus 6 is 10, 10x. Negative 3 plus 3 is 0, so the y's went away. And negative 1 plus 33 is 32. Well, that didn't turn out exactly as I planned, but anyhow. All right. Oh, okay. Okay, so this we can obviously solve. Divide by 10, divide by 10, x equals 3.2. Same goal as when we were doing it the other way, except we didn't know which variable we were going to start out solving for. Found our x, now we need to find the y. You can use either this equation or this equation before you multiplied it by 3, or this equation. Doesn't matter. Caitlin, which one should we use? 4x minus 3y, 2x plus y, or 6x plus 3y? 2x plus y. That looks like the easiest one. All right, so to get the y, we're going to take the value of the variable x out and replace it with 3.2. So 2 times 3.2 plus y equals 11. 6.4 plus y equals 11. minus 6.4 minus 6.4. Y equals 4.6.
3.6.
You sure?
It should be 4.5 and not 4.6.
4.6.
Oh, it's 11. I thought it was 10.
Sorry. So the solution is 3.2 comma 4.6. If I didn't have people that were gone today, I'd be doing this on the board and it'd be easier to see. How about we do this in just a few minutes? When I'm done, I'll just go make copies of these and you can have that for your notes. All right. The last method is called substitution. When do you know to use substitution? This is the one that we didn't get to yesterday. There is no easy calculator process for doing substitution. That doesn't mean you can't change them to the other forms and use them.
Substitution, I believe one would be y equals and the other wouldn't.
For substitution, you're going to have one equation is going to either be in x equals or y equals form. And the other equation is going to be in standard form. Let's see here. I'll just put 10. I don't know what it will equal. This gives you a clue of what you're going to substitute. The one that's solved for the variable. You're solved for y here, and y means this. So you're going to take this expression and you're going to plug it in for y. That effectively eliminates the y's. So something that you'll have to be careful of, if that had said 2y, then we would put parentheses around the 3x plus 1 with the 2 on the outside, and we would have to do distributive property. It would be 6x plus 2. All right, now we have an x value.
That means we can come back into it.
So now we can plug it into either one of these equations and solve for y. This will be the easiest one to do since the y is already by itself. So y equals 3 times 2.25 plus 1. 3 times 3.25. Oh, no, can't do that. Sorry. 3 times. How about if I just go home today? Okay, 6.75 plus 1. 7.75.
our coordinates.
That's it. 2.25, comma, 7.75.